All right, so in our first question on key features of trigonometric functions, I'm going to explain all the features. So the question says f of x is equal to 1/2 cosine of x. And then it says, what is the amplitude of this function? Well, I think the first thing that we need to understand is that in our last section, we talked about the unit circle. Now, the unit circle is based on the ratios of the adjacent, the opposite, and the hypotenuse of a right triangle. But on the unit circle, the radius from here to here is always equal to 1. And then our x comma y is really the adjacent from here to here, and then the opposite from here to here. Now, if I go and I compare those things, okay, so if I start all the way over here at 0, the sine function has a y value based on theta. So the y value is equal to y over the radius, which the radius is 1. So what happens is as theta changes, my right triangle changes, but the y value, the distance from here to here, changes. And so we can graph a function sine of x or sine of theta, but we always just replace this with an x, which can be confusing. But it makes a wave like this, and we call it a sine wave. Now, sine wave is short for sinusoidinous, but it's a wave. Now, in nature, waves happen a lot. So as I go through the unit circle, my corresponding y values, which represents the opposite, right, on sine, it's the opposite over the hypotenuse, which is really just y over the radius. But on the unit circle, the radius is 1. So sine is equal to the y value, and the x value is cosine. So if I go back here, what we kind of need to know is that on the unit circle, x corresponds to cosine of theta, and y corresponds to sine of theta. So this relationship then, oh, and here's another thing that's kind of funny. Tangent, believe it or not, is the same as sine of theta all over cosine of theta, and I'm not going to prove that today. And that's the same as y over x. There's a couple of labels here, and those labels are as such. The distance from here to here is the amplitude of the function, right? And then the period is when it completes one full cycle. So the period is when you swoop all the way around the unit circle. And on a sine or cosine function, it looks like this. Now, cosine is sinusoidinous too, but it's the cofunction of sine, and it's shifted, all right? So that looks more like this. And that's referring to the x values. So see how this distance here, that's the same as this distance here, which is the same as this distance here. So cosine is referring to the x values with regards to theta, and sine is referring to the y values with regards to theta. Okay, so that's what they look like. So with that being said, if I look at this function, the period is going to be from here to here, one full cycle. The amplitude is the middle of the line, or what we call the midline, that goes up to the maximum value. Or it's symmetrical, so it'll go down to the minimum value. So if you want to see that on a graph, if we look at this function, the domain is all the possible x values. The range is all the possible y values, right? the amplitude is from here to here. Now notice that the midline occurs at 1, and notice that the maximum is 3, and notice this number right here in front is 2. Also, the period is 1 full cycle from here to here, and we'll talk about that in a minute. But when we're trying to find the amplitude of this thing, we need to know that the function f of x equals to 1/2 cosine of x. The 1/2 is a scalar multiplier, and that's the amplitude. So the amplitude is just 1/2. So if we look at this problem from here to here, the distance from 1 to 3 is 2, and notice that in front of this right here, we have the number 2. That's no accident.